Stockport Contaminated Land and Remediation for New Developments, delivered by Stockport Metropolitan Borough Council. We will be addressing important questions such as what is contaminated land and legacy waste? What are the environmental impacts of industrial activity? We're going to cover the gas and textile industry, which is a huge part of Stockport's history. How can we remediate the land to remove the harmful contaminants? And what sort of development can occur on this previously developed land, also known as brownfield sites?
What is contaminated land and legacy waste? Contaminated land is land containing substances inside or underground that are actually or potentially harmful to health or environment. Legacy wastes are the wastes that have been collected and kept for years at some barren land or a place dedicated for landfill, an area to dump solid waste. Pollution can also occur naturally due to the geology or agricultural use of the area. Environmental impact of legacy wastes. Legacy wastes not only occupy large space but also become a breeding ground for pathogens, flies, malodors, and a generation of leachate, which may lead to water contamination. They also contribute to generation of greenhouse gases and cause risk of uncontrollable fire. In the process of production and operation, some key polluting enterprises have discharged a large number of waste gas, wastewater, and waste residue to the environment, in which waste gas and wastewater have been discharged and run away from the factory, and solid waste in many enterprises have a certain amount of storage, some even piled up. The disposal of these solid wastes became an important environmental issue after the relocation of enterprises to stay. Here is the picture of the site of an abandoned Portwood gasworks in Stockport. The gasworks cannot be torn down because there are still remaining toxic wastes in the soil. If torn down, the gasworks might lead to more leakage of these wastes.
During manufacturing, waste products of gasworks are often buried beneath or adjacent to the site. Unfortunately, it is not always cleaned up through proper remediation actions when the site is decommissioned. Consequently, this contamination enters the surrounding soils and water sources through direct contact or via surface rain runoff. A list of likely contaminants related to a gasworks is shown on the left. The most common are tars, oils, polycyclic aromatic hydrocarbons such as naphthalene, and oxide wastes. Stockport's water sources have been found to be contaminated and polluted near old industrial sites. The Etherow and Mersey River sections, as shown on this map, have been deemed as being of poor quality regarding pollution. There are consequences for humans and animals when contaminants enter the soils and water systems. Harmful contaminants are released through weathering processes called biodegradation and dissolution. Once these volatile organic chemicals are released, they can enter humans and animals through ingestion of soil or water, inhalation of harmful gases, or through direct skin contact. The image here shows how close the site of Portwood Gasworks, which is an abandoned gasworks in Stockport, is to the River Goyt. It becomes clear how easy it can be for these dangerous substances to enter the surrounding waters. There is also strong evidence for certain contaminants, such as naphthalene, being carcinogenic for animals and therefore potentially for humans too. The current and most common method of remediation of decommissioned gasworks sites is to dig up the site under controlled conditions to prevent the release of more contaminants. Once dug up, the harmful industrial waste can be removed from the ground and then incinerated. Once waste is safe, it is disposed of on a specific designated landfill for industrial waste. An issue with this method is that soils around gasworks are heterogeneous environments, meaning that there is a mixture of chemical components. A specific chemical removal process is likely to be unsuccessful in removing all the different types of contaminants in those soils, whereas a new technology, microbial removal, can dispose of all the biodegradable compounds like phenols and cyanide. However, this is a technology that is still being developed and potentially has its own limitations too.
The main environmental effects of the textile industry are mainly the high levels of chemical loads being discharged, resulting from high levels of water consumption and use of harmful chemicals in this area. Others include problems with packaging and solid waste production, unpleasant odours from the bleaching, dyeing and the printing process. The textile industry uses high amounts of water as it is used in every step of the production process, mainly from transporting the chemicals and dyes to the textiles and washing the material before moving on to the next step. The average amount of water used for a medium-sized textile factory is about 1.6 million litres a day, of which 1/5 is then contaminated. This can lead to groundwater contamination, which can then induce serious health problems, as well as issues for surrounding wildlife and habitats which depend on clean water supply. Textile mills need large amounts of energy in order to heat, dry and operate the machinery, which drastically increases the carbon footprint of this industry. In 2008, it was estimated that to produce the 60 billion kilograms of fabric produced that year, 1.07 billion kilowatt hours of electricity was needed. These energy sources produce greenhouse gases, which are commonly known to detriment the Earth's atmosphere and contribute to global warming. Air emissions are also a toxic product of the textile industry, including dust and lint, oil fumes, acid vapour, solvent mists, odour and boiler exhausts. Repeated exposure to these hazardous emissions can cause serious breathing difficulty and lung conditions. Textile wastewater remediation is more difficult than traditional wastewater remediation due to the chemical stability of the pollutants. However, it is achieved by a wide range of technologies designed to remove toxic coloured dyes from wastewater. These include physical processes such as membrane filtration, sorption methods such as coagulation combined with flotation and filtration, and biological methods such as aerobic or anaerobic microbial degradation. Soil remediation from chemical spills or leakages can be remediated using a number of different methods depending on the pollutants on site. Bioremediation involves enhancing or controlling biological processes to reduce the contaminants to targeted levels. This technique is widely used to remediate fuel and hydrocarbons from the soil and take upwards from 1 month to carry out. Other examples of soil remediation for organic contaminants are chemical oxidation, soil washing and thermal desorption, where heat can be used to treat hydrocarbons in the soil. Large mills can more often than not be an eyesore to the current urban skylines, as well as cheaply constructing buildings using dated methods. These can be converted into chic apartments or office space with a strict safety focus during refurbishment. Throughout Stockport, there are multiple examples of this. Refurbishment of these sites means there is no visual pollution and also mean that no injuries would be sustained from a potential collapse if it is not maintained.
Brownfield sites are sites of previously developed land, like an old gasworks or cotton mill. With the right remediation practices, all brownfield sites have the potential to be redeveloped. So far, Stockport Council have around 370 brownfield sites that have been scoped for redevelopment for potential housing and employment uses. Utilising brownfield sites for future developments is important to preserve the green areas that would otherwise be used. The Brownfield First policy ensures that suitable, previously developed land is prioritised for redevelopment over green spaces and countryside. Over the last 15 years, Stockport has ensured that at least 90% of new development has been delivered on brownfield sites with the aim to protect Stockport's green belt. Stockport Council further aim to reduce pressure for development on precious greenbelt sites. Brownfield redevelopment not only cleans up environmental health hazards and improves aesthetics, but it also acts as a catalyst for community regeneration, especially when communities are involved in choosing what can be built from what people feel is missing in the area. Sustainable development is key for a green, healthy future, and utilising brownfield sites will help Stockport achieve its sustainable development goals by providing affordable housing, creating job opportunities, promoting conservation and wildlife, and offering a shared place for play and enjoyment. Thank you for taking the time to watch our video. We look forward to hearing anything you have to say.